I don't know if you can see it in this photograph of the Earth. Do you see that haze right there? That very thin film? That's our atmosphere. When you compare it to the Earth, that's just a very thin vapor that clings to the Earth. But it's a very important vapor because it's what blocks out a lot of ultraviolet radiation and harmful cosmic rays and things that would cause us to age quite rapidly and have all kinds of cancers if we didn't have it. Also helps keep the temperature of the Earth at a relatively stable temperature throughout the year. It's like a blanket. It is a blanket of air. This is a photograph of the atmosphere taken from the space shuttle. I guess they rolled down the window and put the camera. I don't think you can roll down the window. That would be pretty dangerous. But anyway, through the window of the space shuttle, and you can see the different layers. It would make sense if we have layers of oceans that we have layers within the layers, right? And so we have layers within the layer of the ocean of air. And you'll learn these. It's a test question, in case you're wondering about that, knowing the layers of the atmosphere and knowing them in order. The outermost layer, which you see here is a dark blue, is called the thermosphere, or the ionosphere. Same layer, two different names. Thermosphere, ionosphere. It's called the thermosphere because that's where the solar radiation first strikes the atmosphere, so it's quite hot. And that produces lots of ions, therefore the ionosphere. Aristotle taught that there are four basic elements. Anybody know what they are? The terrestrial elements that make up the Earth?
Fire.
Nope. Oh, fire. Did you say fire?
I said
fire. Yeah, I'm sorry, I said iron. Fire, water, air, and dirt or earth. Earth, wind, and fire. No. Earth. Yeah, I guess that's right. Earth, wind, fire, and what are we missing?
Water.
Water. Earth, wind, fire, and water. The four terrestrial elements. Well, each of the four terrestrial elements they're a mixture of form and matter. And if they have more matter, they sink to their natural place. And so, which of the terrestrial elements do you think has the most matter out of those four and the least form? Earth does. It's the heaviest, and so it sinks to the very center of the universe, which is the most base you can ever imagine, the center of the universe. And then which of those elements has the next amount of form and water above that? So we have earth, and then we have water above that, then the next air, and then the next fire. So in Aristotle's universe, fire has the least amount of matter and the most form, which would cause it to want to go above everything else. And so when you look at a fire, a campfire, and the fire is leaping up, it's because it's trying to get to this higher level above the air. And so Aristotle believed that's where it was going, and it would go up there, and it would exist out. And so outside the atmosphere in Aristotle's world, there was this ring of fire that encircled the earth. And beyond that, there were no terrestrial elements. Beyond the ring of fire, there was only the fifth element, the fifth or the quintessential element, which was ether, which was perfect, pure form. And that's what made up the sun, the moon, the stars, and all that. They were perfect. So when someone looked up at the moon and said, Aristotle, look, the moon's got those brown, those dark splotches on it. I thought it was supposed to be perfect. Aristotle would say, well, there's a ring of fire there, and that's soot. It's like on the wind, there's a crystalline sphere, and you got some soot on that, and you're looking through the soot. And they said, yeah, makes sense to me. Makes sense to me. And that indicates that there's fire out there if there's soot. Of course, someone could say, well, soot, that's like earth. So what's it doing out there? It should be. Nobody said that, I guess. So anyway, you have this ring of fire, and so Aristotle was pretty close. There is a very hot layer of the atmosphere called the thermosphere. Below the thermosphere, this light blue area is called the mesosphere. Thermosphere, mesosphere, and right at the base of the mesosphere, there's a very thin, you can see the upper part of, or the lower part of it there, where you have a series of a very well-defined strata. That's where the ozone layer is. Probably, you guys heard of ozone, right? That's where the ozone layer is. It's called the stratosphere. So you have the thermosphere, the mesosphere, the stratosphere, and then below the stratosphere, which is right here, you have this. Has anybody read far enough to know what that layer is?
Troposphere.
That's the troposphere. and you see the clouds. See the clouds go up as far as the stratosphere and they stop. Weather takes place just in the troposphere, and that's you can see the weather going up and stopping right there. Also, you can see that the light coming through the troposphere is orange and red, and the light in the higher levels is blue. And the reason is because in the troposphere there's a lot of dust. The weather or the winds is kicking up the dust, and as the dust filters through the atmosphere, especially close to the Earth, as light comes through at an angle during sunrise and sunset, it causes the cooler colors to be absorbed. The dust actually absorbs the cooler colors, like greens and blues in the electromagnetic spectrum. And so that allows the hotter colors, the oranges and the reds, to dominate. And so that turns the sky orange and red because the dust is absorbing the cooler colors. So now you know why sunrise and sunset is painted orange. And then when you look straight up and you're looking through a smaller portion of the troposphere, then the Mesosphere and Ionosphere dominate, and the concentrations of gases there cause a dispersion of light that produces the cooler colors, such as blue. So when someone asks you, why is the sky blue? I just told you. See how the sunlight there is shining along the edge of the Earth? That's where all the dust is. When the sun gets high enough, the sky won't be orange anymore. It'll be blue because the sunlight is coming straight down and not through that layer of dust.